This is practice 1, number 3, series circuit. So let's go ahead and read the problem. We have two resistors are connected in series to a 10-volt battery. Resistor 1 is 3 ohms and resistor 2 is 2 ohms. So now the resistors are not equal. So resistor 1, sorry about that, is 3 ohms. And resistor 2 is 2 ohms. And our battery has 10 volts. And so that means going into our battery, there's 0 voltage. Coming out of the battery, there's 10. And now we can solve the problem based on what we have. First, we know what the resistance of each resistor is. And so we remember that the total resistance in a series circuit is going to be the sum of all the resistance of all our resistors. So we have this 3 ohms plus 2 ohms is going to give us 5 ohms, and that will be our total. So we have 5 ohms as our total. Now we have to find out what our current is. So we have our total voltage is equal to our total current times our resistance total. We have 10 volts is equal to some number I that we don't know times 5 ohms. And to isolate the variable, we're going to divide by 5 ohms, and that's going to give us 2 amps for our current. So this will be 2 amps. And we know that in a series circuit, it's going to be the same. Okay. Now we can also find out what the voltage drop is. Remember that in this part, this is the voltage drop. And it's not going to be the same because the resistance values for each resistor are different. What we can do is solve it using Ohm's law. So the voltage drop for 1 is going to be 2A times 3 ohms, and that will give us the voltage drop of 6 volts. Now the voltage, that should read volt. So voltage 1 is going to be 6 volts. Now for the second one, we'll have a current of 2 amps times 2 ohms. That's going to give us 2 times 2 is 4 volts. And to double check, make sure that these two, the voltage drop should equal our total, which they do. 6 volts plus 4 volts is equal to 10. So now going back to this, we're going to fill it out. Remember our ammeters, read a number, and this is 10, this is 10. And so resistor 1 has a voltage drop of 6. That means we're going to take away 6, and that'll give us 4. Now for this part, it stays at 4 and has a voltage drop of 4 for resistor 2. That means 4 minus 4 is going to be 0. This will be 0 all the way up until the negative terminal. And now really quickly, we have our battery. We have our ammeter. So last time I didn't add the ammeter, this time I am. It really is up to you if you want to add it or not. And then we'll have our ammeter here also. Okay. Whoops, our resistor disappeared. All right, so now we'll write down what it says in our ammeters, which is 2 amps. This says 2 amps. And we can go ahead and label it with our letters. So A, before the battery, after the battery. And then I'm not going to include the ammeter because it's kind of like a wire, right? But this wire just tells us what the current is. So before the resistor, after the resistor, before and after the resistor. And then that's it. So we have A, B, C, D, E, and F. So we only go up to F here, and we'll go, let's see, we can do 2, 4, 6, 8, and 10, or we can just do 5 here and 10. So this will be 2.5 and 7.5. All right. So let's go ahead and graph it. So at A, we had 0. Then B, when it leaves the battery, there's 10 volts. At C, there's 10 volts. At D, we're at 4, so we're just below the 5. And then we're still at below the 5. And then F, we're back down to 0. And then, just to re-emphasize, at A is also at 0. So then this shows us the voltage drops of from each resistor. So remember that this is resistor 1, and this shows us resistor 2. Resistor 1 has a bigger voltage drop, so we should see a bigger drop than resistor 2. All right, that one was pretty easy. So remember, if you have any questions, make sure to email me.